Hey there.
Hey there. Today's video is going to be about comparison. Didn't we do this same bit last time? You got to do the whole video last time. I was just in the first shot. That's not fair. It's my turn now. Really? Besides, the bit still works, you know? Like, we're different. They're going to have to compare us. They're going to like me better. You're impossible. Maybe. Okay, so why do we use comparison?
You need to be able to compare things to see if things are like, I keep saying things.
Comparison lets you draw conclusions, I guess.
To see how something affects something else.
Welcome back to Significantly. Today we're going to take a look at comparison because, well, it's like kind of at the root of all science.
I think comparison is important because it gives context to any data you have.
Comparison does a lot more than just provide context, though. It's the core technique that we use to build scientific knowledge, right? Like, we can learn about one part of nature by comparing it to another. So, in the last episode, we started to take a look at this fruit fly experiment. Remember? Scientists provided sex-deprived flies with a choice between alcoholic and non-alcoholic food, and then they kept track of their decisions. But this alone wasn't yet enough to draw conclusions about what was going on. So, let's go a bit deeper. It's tempting to look at this table over here and, because the alcohol side is longer, assume that sex deprivation causes alcohol preference, but that's not actually a safe assumption to make yet, because what about flies that are not sex deprived? Do they behave in similar ways? See, we need to make a comparison.
We have to look at a different group of flies and see how they compare to the sex deprived flies. Recall that the scientists in this study observed two groups of flies at the same time. The first group of flies was having a lot of sex, while the second group was having none.
That's what was different between the two groups, but for the purposes of comparison, what's actually more important is what was the same.
All the flies they tested were the same age. They came from the same lineage, they were raised on the same food, and in the same place. They were cared for by the same people. In other words, their environment was extremely controlled.
Controlled here means that the scientists put a tremendous amount of effort into ensuring that the groups of flies that they were studying were exactly the same, except for one critical factor. In this case, whether or not the flies were having sex. Sometimes you'll hear one group being called the experimental group and the other group being called the control group, but in reality, both groups are exactly the same except for one factor, a variable, that's being manipulated by the scientists. Both of the groups together make up the whole experiment because that's what's needed in order to make the kind of comparison that can hold up to statistical scrutiny. We need to ensure that all of the conditions remain the same so that we can be confident that any differences we observed are caused by our experimental manipulation only. It's a pretty simple point, but it's one that's surprisingly easy to miss among all of the other details that are required to set up a good experiment. Scientific knowledge is often relative. We understand one thing by comparing it to another.
What role does comparison play in science?
It makes sure that what you're testing for is the actual thing that is creating changes, I guess.
Can you say more?
So if you compare something that changed to something that didn't change, then you can see what is causing the change.
If you compare something that's changed to something that didn't change, and you ask the right questions, then maybe you'll be able to figure out just what's causing the change. And the kinds of questions that scientists prefer to ask are those that make especially clear exactly what it is that's being compared.
By controlling our experimental system like this, we can more easily ask specific questions, from which we can develop a testable hypothesis. First, we ask, what is the difference between sexually deprived and thoroughly mated flies? Then, our hypothesis is, sex-deprived flies seek out alcohol more than thoroughly mated flies.
The crucial thing about a hypothesis is that it contains a testable proposition with clear options that evidence might or might not support. Flies will be more attracted to alcohol, or they won't be. A good hypothesis will identify experimental and control groups and make a prediction about how those groups will behave. When all those pieces are in place, we can run the experiment with confidence that our results will indicate whether there's truly a difference between our two groups. Now, there might be, or there might not be, but if we design the experiment well, the groups will be easy to compare one way or the other to make conclusions. Scientists rely on comparison in a bunch of different but interconnected ways. It's not just about making sure that you can compare your experimental groups and your control groups, it's also about asking the kinds of questions and making the kinds of hypotheses about those questions that can be compared to one another. This is why scientific thought can sometimes get the reputation of being overly rigid while still seen as clear and precise. Of all of the different kinds of questions that you could ask, scientists limit themselves to those questions that can be answered using comparison.
You're trying to compare it to something. It's all about comparing things to other things.
So we ask questions with yes or no answers, and we rely on a lot of math. We design experiments with extremely rigid control. And what all these techniques have in common is that they allow us to work with ideas that are clearly comparable by precisely comparing one group to another group and making sure that there's only one thing different between them, the thing that we're testing. We can come to know how those groups behave differently. How else would you be confident in what you know?
I don't know. That's what I learned in science class.
Well, in the next video, we're gonna get into that in a bit more detail. I'll see you then. In this video, we spent some time looking at the concept of comparison and how scientists use comparison to produce knowledge. So now I want to hear from you. Why do you think that comparison is an important part of our scientific method, and how can we use it to understand our world better? Take a couple minutes and write down some thoughts that you have in the comments below, and then we can have a conversation over text that is a little bit more sophisticated maybe than what's possible just in this video box, right? Because interaction is important, it helps us learn. So tell me why you think comparison is important. I'll see you down in the comments. Okay, bye.